Thank you so much. It's exciting to be here. Welcome everyone to the Futurist Expo. My name is Tushar Chugh and I work at Google. Today I'll be talking about the future of software engineering and how it can be transformed using the generative AI. So during this 30 minutes or so, we'll be covering about what is the current state of software engineering, how generative AI is driving the revolution in the world, not only to the software engineering domain, but to the other domains as well. Then we'll talk about what are large language models and in the current set of world, where are they being used? And then we'll be talking about how generative AI and large language models can be used to transform the software engineering world. And in the end, we'll talk about some of the key challenges that we have in making this happen. So we'll get started. Yeah, so talking about the current state of the software world and like the tools and the processes that software engineers they have at their disposal. Um, Software engineers have at their disposal currently. So the first one is in the integrated development environments, we have code of autocomplete. What does it mean? Like it's like when a software engineer is writing the code, the ID integrated development environment could suggest the users what the next function name would be, or like in complete automatically complete the variable that user was able to write. But in the current set of world, it is only limited to like single line or single statement or maybe a couple of lines. And autocomplete has been there now since more than a decade, but AI is now here to transform that kind of feature. Then the second one that software engineers use is the continuous integration. There are several tools outside, like both open source and closed source tools, where they help us as a software engineer in doing continuous integration. So with continuous integration, what we mean here is like when somebody like a software engineer writes a software, it has to be deployed on like in different kind of environments like staging or production, and oftentimes like there could be some issues when we are deploying, and they are like in those releases it can block, and that can hamper the process. So there are these processes like where they check if the build of the code is happening properly, if it is passing all the test cases, integration is fine, like all these tests are working as expected, and then finally it allows like to have that green build. So these are the kind of tools that are at our disposal currently. And finally we have these debugging tools. So something when it is not working correctly, right, it might be a bug in the code, it might be an issue with the integration, or it might be something that we didn't foresee before. So there are a lot of debugging tools available for different languages, or like even across the languages. It could be like debugging for like language in C++, like Valgrind tools that we might have. We might even have some performance analysis tool to debug the latency concerns. And then we might even have some tools to debug, like the RPCs or the APIs that software developers very frequently use. So this is the current state, and these are the current set of tools that we use. And let's see, like how AI can help us in making these better, and having more tools at our disposal. So moving forward, first we want to understand like what are the different revolution that we have went through as a world. So first one is like the invention of steam power. uh, Steam power revolutionized the how the industries work, and it was a key driver for the industrial revolution. We were able to replace some of the manual labor with the machines, and that massively boosted our productivity. And similar thing we observed with the transportation industry as well. With transportation, like when the steam power was invented, it gave the wave to the steam engines, and we were able to not only like transport the goods and people across the world, and also like inside the countries, like that have massive land and stuff. Like we were able to transform a lot of goods and services through these steam powered engines. Then came the advent of electricity, and that also had a very major impact on like the human civilization in the last couple of centuries. It transformed like the way we live and work all together. The lighting in our houses, the heating, like we can't imagine how to live without electricity right now. And then we had the invent of information technology, and now like this presentation is possible because information technology is there. It revolutionized the way how we store information, how we access the information. All the information like was before contained in the books and like in the writing or people had in their brain, but it helped us in storing this information and making it accessible to the entire world. So this was the first step for democratizing the information. And now we have AI at our disposal, and let's see how it is revolutionizing the world. So before we jump into like AI and the software development, for us one term is important, that's called the large language models. These large language models are essentially huge machine learning algorithms that can predict, recognize, and generate human languages. Imagine like the size of this is that we can't even fit a model like the especially the bigger ones on like a single computer that we have. Sometimes we need like multiple machines to do the inference or training for these models. So there are a couple of steps involved in training the large language models. First is pre-training. In pre-training the language models, a model is presented, uh, the whole web corpus, and like the other things like books and like all those other things. This is like a massive amount of data, and then the model learns how to store this in like tens or hundred or billions of parameters that the model has. And once these are pre-trained, the model learns how to predict the next word in the sentence. uh, like for example, if I say how are, it can predict the next word could be you. But these models are essentially not intelligent in that perspective. They just know how to predict the next few words. So like to make them better and to like generate the responses that we want from them, we do a fine tuning for different tasks. It could be like let's say if we want to um, search something on the web, like then we can when we ask it, we want the return output to be specific to what humans want. So we don't want like the models to hallucinate or give us false information. Or it could be like paraphrasing a sentence where we want the English language or the grammar to be correct for that particular sentence. Or the task could be about like translating from English to some other language. So these tasks, for these tasks, a model is fine tuned so that like the precision and the recall for the model is better for those kind of tasks. And these more often than not, like these LLMs are generic. For example, like the Bard or Chat GPT would have seen that you use them for a variety of tasks, but then these are also fine tuned for specific tasks. For example, in software engineering, if you want to use these large language models, we'll take the data specifically for software engineering and train the models so that they generate the output that we want from them. So, like in terms of the terms, we also call these as large models. We also call them as large language models, and this is also generative AI because like the model is able to generate the next few words in the sequence when our data is presented to it. It's not like fully intelligent as it appears it is giving the output. So why are these large language models different than the previous machine learning algorithms that we had? So with the previous machine learning algorithms, we only had like few hundred or few thousand parameters, and they were only able to encode partial information that was presented to them. They were pretty good at like learning the patterns in small data, but in large data, it was very hard. So one example could be like, if you give a traditional machine learning model the data about weather, like how the weather was last year and how the weather it has been in the past few days, and maybe a couple of more features. It would be able to predict, like whether it would rain or not tomorrow, or what would be the weather like tomorrow. But like if you ask it in a natural language, then they don't have the ability to answer in those terms. So these two things large language models are solving for us. So first of all, it is able to learn and store the knowledge for the massive data corpora that it is given. And also it changes the way how we can interact with these models in a natural human language, and not only in like one language but in multiple languages. So generative AI has already transformed the industry, like multiple industries with their capabilities. As we, like shared that they are like, general, but they can also be fine tuned. A lot of startups and other industries, they are using it in their general forms, but in the specific application. It could be, like used in retail, when you can ask like, I want a product that satisfies certain needs in a certain cost range. You can form your query in a very natural language, and then the retailers can show you the results based on the natural language that you shared. Or it could be, like let's say about the media and entertainment as well. People are able to generate the videos, the reels, even the books. Even myself, I have published a book based on generated based on generative AI. So both the text and the images can be generated in those forms. There are other areas as well, like in healthcare. When you go to the doctor in the US, they have to map your illness or your conditions to some kind of code that they can send it to insurance. Generative AI can also help in taking the doctor's notes and generating these codes, and this is currently a very cumbersome process right now. So there are like variety of cases where generative AI can be used. And last but not the least, generative AI is also transforming how video games are being there. In the future, you might be able to see how, like in the real time, you a scene can be generated based on the previous actions that you take in the games. So we are in like at an exciting times, and the industry would be all these industries would be massively shifting gears with the generative AI at their disposal. So now let's see how generative AI can transform the software engineering world. So these are some of the key themes that I believe where Gen AI would have the major impact. The first one is code generation and assistance. Second is testing and quality assurance. The third one is maintenance and evolution of software. Will we go through in detail for these three categories. So the first one is code generation and assistance. So the first task of, like the primary task of the software engineer is to generate the code, right? Like they have to write the code. And a lot of times it could happen, like they have to write some boilerplate code. It might be, like reading the data from the CSV, or it could be like, storing the data somewhere else. It could be, like doing some sorting kind of algorithms. So these things are like very boilerplate, and like very cumbersome for like the software developers to write. Software developers usually like like to write more challenging stuff, but these boilerplate code is not fun. So generative AI can help us in generating this code automatically. And how it can help, let's say if we just give it like a function name, or maybe if we just give it a comment, it can generate the code. For example, if you see on this right side, like imagine a company, and like we want to see what are the top stores, like they are in the retail business and they sell stuff like maybe they are the coffee chains, and they want to see their top performing stores. So we want to write a function that retrieves all the stores and sorts them in their descending order of the revenue. So we can write this as a comment, or we can write this as a function name like in the second block. And in those cases the code can automatically be generated using these large language models, or the generative AI. Then it not only can help the software engineers, but imagine you are a leader, or like a CX of a company, and you have, let's say, a UI given to you where you can play with the data. So if you write these questions in the natural language that you want, like the top four performing stores, or you maybe, you might have more detailed questions. Tell me, like something special, why these top performing are at the top and why these bottom ones, why they are not making that much sale. And you can also ask, maybe, can you pull some information online for this specific store and this area. For example, in New York, maybe there is some event happening, that's why the sale is increasing, whereas like in other area people are preferring some other brand, and our brand value is going down. So all these questions can be asked by the CXOs, and the code can be automatically generated in the background. It can run in the background, and the final output can be shown to the users. So it can be used by the leadership team as well. Then, for people who are learning how to code, this can not only write code for them, but it can explain the code at every step, on how these can be, like how this code was written, what are the best practices, so that, like the future of software developers, they are better trained, and they learn what are the good coding practices in the industry. The second one is about testing and the quality assurance. Uh, it's funny, but when as a software engineer, sometimes it takes more time for us to write test cases than to write the code. Sometimes the code might be a single one-line code, but the testing could be, like hundreds of lines, and it can be very, very challenging to write those test cases. And in other cases, the test cases could be like very simple boilerplate. And the third case could be, humans might not write comprehensive test cases. In all these three things, generative AI can help in writing good quality, comprehensive test cases, and assist the software developers. And how it can do is, like we can straight away ask, like write the code, like the test cases for the entire functions in the file. Or if we are making like a small change in the code, generative AI can figure out what changes are there, and it can generate the code. Or it could be, like the test driven development, where we have the function name and the test cases are automatically generated given the function definition. So this is like, the first primary use case in the testing. There could be other use cases as well. For example, like it can, if the gen AI models can have the access to the historical data where the bugs would have happened in the code, and where, like the production crashes happen, and if some developer makes those similar errors, those can be, caught by the generative AI, and it can suggest to the engineering team, like, in their environments, that okay, like this could be a potential issue, you might want to take another look. And and there could be one more use case as well. It can, it can also like generate the data. For example, like, for testing in machine learning or computer vision domain, there's a lot of testing involved with the data. It can also create like some synthetic data that can be helpful for testing. And finally, Gen AI can also help in maintaining and the evolution of software. Uh, like, in a startup, it's pretty easy to come up with like new software, and, like the software velocity is very, very fast. Whereas like in the big industry, or when, like a software becomes medium scale, the startup becomes at medium scale, it's very, very challenging to maintain and evolve the software. There are few challenges related to that. First, it could be, like different developers, especially, like the new hires. They might have different readability guidelines, or, like their coding, uh, their coding structure is very different than the current code structure. So we want to maintain that the entire code base is very cohesive and readable, and is very efficient. Second, it could be, like there are time to time migrations. So for example, if we want to migrate from one version of C++ to another version of C++, that can take like, a long time to migrate. And it could be, like different libraries or APIs that we want to migrate as well. A lot of time for engineers is spent in these kind of migrations, and oftentimes these can be very challenging for the large code bases. uh, so in all these cases, Gen AI can help. It could be, like maybe in the beginning, humans can handhold and, assist Gen AI to migrate, let's say, from one version to another step by step. But in the future, once it has seen enough patterns, then it would be able to like auto migrate. And then like all these companies, like at Google, we have C++, Python, and Java readability, and all the developers are suggested to adhere to those guidelines. So these Gen AI can also suggest people like how to learn and maintain the code base on these readability guidelines. And then like with APIs, when a company has like public APIs or even for internal APIs, they like there's a documentation, and oftentimes it's very hard to maintain the documentation. It's a cumbersome task, and it takes like a decent amount of time for the engineers to update these documentation. So these Gen AI can also write the documentation which is very crisp and clear for others to read. So these are, like the primary three areas where I believe that Gen AI would have a major impact in the software engineering world. And with that, like there would be few challenges that we will have, especially like right now we are at the initial stage of AI being developed and AI being deployed in these domains. So the first one here would be the accuracy. Right now Gen AI has a problem that it can hallucinate. It can give like false answers. For example, if it is suggesting you like some autocomplete code, or like like it is telling you that okay, this variable to use, that variable might not even exist in the code base, but it might think that this is the most likely candidate that it is having. So we still need to solve the problem for accuracy for these large language model and Gen AI applications. Second is the cost. The inference cost for these models is very high right now. So right now we need to see like where the inference, at what point this inference can happen. So for example, if you want to generate the entire test case file, then it might be okay because it saves like a lot of engineering hours with just like few dollars of code. But if you are generating like one word, it may or may not be helpful in those cases. Going forward, the costs are also coming down with the like new compute and new scale that is coming into the picture. uh, Last thing is the scale. With so many developers around the world right now, there is like some shortage of GPUs and like TPUs that we have, but eventually we'll be able to cater to that scale. uh, like this is just the beginning, and there are a lot more applications that Gen AI would be unlocking in the software engineering world, and I'm pretty excited to see that happening in the future, and I hope you are too. Yeah, this is from my end. Thank you.